The last reaction that we identified, what was oxidized and what was reduced, cannot be balanced in the normal way. We can't change the coefficients and make this balance. Notice there's a hydrogen on the left side and there's no hydrogen on the right side. So we need a special technique to balance redox reactions. Balancing redox reactions can be done if you follow these steps. And you're going to apply these steps to each individual half reaction independently. So first thing to balance is anything that's not an oxygen or a hydrogen. Next, balance oxygen atoms by adding water. We're focusing on reactions that take place in solution, in aqueous solution, and we have plenty of water, so we can add the water where we need it. We're going to balance hydrogen by adding H+. Remember, H+ was the same thing as hydronium. Hydronium is present in every aqueous solution, which is why we can add H+ when we need to. Step 4, we want to balance the overall charge of our half reaction, and we do that by adding electrons to the side where we need them. Step 5, add together the two half reactions, making the number of electrons lost equal the number of electrons gained, so that the electrons have to cancel. Step 6 is only if the reaction takes place in basic pH. We can't have a lot of hydronium floating around in basic pH, so we have to get rid of the hydronium by adding hydroxide, and we have to do that to both sides. And if you prefer to write hydronium rather than H+, you can turn H+ into hydronium just by adding water to both sides of the reaction, so it stays balanced. So it's a lot easier to see with the specific example. We're going to balance that previous unbalanced reaction, and this reaction happens to take place in acidic pH. So the first thing to figure out is your half reaction. IO3 minus turns into I minus, that's one half reaction. And HSO3 minus turns into SO4 2 minus, that's the other half reaction. Iodine has to turn into iodine, sulfur has to turn into sulfur, so we're able to separate the two fairly easily. If not, you can always assign oxidation numbers and figure out what was oxidized and what was reduced. So let's take the half reaction on the left first. The first thing to balance is iodine, and there's one on both sides, so it's already completely balanced for iodine. Then we want to balance the oxygen. There are 3 oxygen atoms on the left, none on the right, so we need to add 3 waters to balance out the oxygen. Notice water contains hydrogen, which is why we leave the hydrogen until the oxygen is balanced. We just added 6 hydrogens to the right, which means we have to add 6 H pluses to the left. Then we want to figure out the overall charge. 6 positive 1s and 1 negative 1 means our reactant side has a net positive 5 charge. The product side is a negative 1 and 3 neutrals, which is a net negative 1. So the only way to make the two charges the same is to add 6 electrons to the reactant side. We're going to do the same steps to the other half reaction. First we would balance the sulfur, which it already is. Then we would balance the oxygen, 3 on the left and 4 on the right, so we need to add 1 water to the left. That makes a total of 3 hydrogens on the left, so we have to add 3 H pluses to the right. And next we're going to balance the charge. The reactant side has a neutral water and a negative 1 anion, so the net is a negative 1. The product side has a negative 2 and 3 positive 1s, so that's a net positive 1. The side that's more positive always gets the electrons because the electrons have a negative charge, and in this case we have to add 2 electrons to the product side. So I just rewrote the two half reactions. Now we want to add together the two half reactions to give the overall reaction. But notice one half reaction has 6 electrons and the other one only has 2. So we're going to have to multiply this half reaction by a factor of 3 to make the electrons cancel. So I need 3 water. I'm going to change all the coefficients, multiplying by a factor of 3. And so after I multiply by 3, now when I take my two half reactions, I can add them together, and the first thing I'm going to double check is 6 electrons lost cancel 6 electrons that are gained. I can also simplify 3 water cancels with 3 water. 6H plus will leave me 3H plus on the product side, and so I'm left with now I can leave it like this because the solution was acidic that this reaction was carried out in. If I wanted to rewrite this, I could add 3 water to the left and turn 3H pluses into 3 hydroniums. But then I would also have to add 3 water to the reactant side. As a quick check to make sure your reaction is balanced, you want to calculate the charge. Everything should be balanced. Atoms and charge has to be balanced. 3 -1 anions, so this is a -3 charge, plus a -1, so my reactant side is a -4. The product side is -1. 3 times -2 is a -6, and 3 positive ones is a +3. That's -7 and +3 make -4. So if you check everything, charge and atoms, this will be a balanced redox reaction.